السلام عليكم. إن شاء الله في هذه المحاضرة نتطرق للبروتين composition, structure, certain type of the protein and their function. بس ملاحظة أنه في كل سلايد هناك علامة السبيكر، تضغطون على السبيكر حتى تستمعون إلى الصوت مع السلايد. Proteins are large biological molecules with molecular weight up to 2 million dalton. The protein weight is measured in 1,000 dalton or kilodalton. Proteins are made of amino acids linked into linear chain called polypeptide chains. Amino acids link between each other by peptide bond. This peptide bond is formed between the carboxyl and amino group of neighboring amino acids. Proteins are formed by one or several polypeptide chains. The sequence of the polypeptide chain is defined by gene with genetic code. There are only 20 standard amino acids that exist in living organisms. Sometimes these amino acids are chemically modified in the protein after protein synthesis. بمعنى البروتين is a large biological molecule consists of a broad sequence of polypeptide of the amino acid. عبارة عن سلسلة من الأمينو أسيد. These amino acids link together between each other to form the protein. Protein, so it differs in the number and sequence of the amino acid and also in the function according to these number and sequence of the amino acid. The protein is under the control of the gene, under the genetic control. Each protein has a specific code for its synthesis. Proteins are the major component of the living organism and perform a wide range of essential functions in the cell. While DNA is the information molecule, it is protein that do the work of all cells, microbial, plant, animals. Protein regulates metabolic activity, catalyzed by chemical reaction, and maintains structural integrity of the cells and organisms. لكن البروتين has many different functions. It is important for the living organism. It is previously thought كانوا سابقا يعتقدون انه البروتين هو المسؤول عن انتقال الصفات الوراثية بين الافراد، لكن بعد اكتشاف الدي ان اي وجد ان الدي ان اي هو المسؤول عن انتقال الصفات الوراثية، لكن البروتين has many different functions. An example هو to regulate metabolic activity, catalyze biochemical reaction, and maintain structural integrity of cells and organisms. Amino acids are the basic structural unit of the protein. An alpha amino acid consists of an amino group, carboxyl group, and hydrogen atom, and a distinctive R group bonded to carbon atom, which is called the alpha carbon because it is adjacent to the carboxyl acid group. An R group is referred to as a side chain. مثل ما تلاحظون في هذا السلايد إنه structure of the amino acid consists of central carbon atom اللي هو called alpha carbon atom، نأخذ التسمية اللي اجت alpha amino acid, and it is called alpha because all four groups are tied to the central carbon atom. At the left there is an amino group, and the right hand there is a carboxyl group, while on the other side was hydrogen group and R group. The R group different from each amino acid. It might contain simple like methyl molecules or a large compound attached to the carbon atom. These R group determine the physical and chemical properties of the amino acid. بمعنى الاختلاف بالآر جروب راح يحدد لي الكيميكال and physical properties، الاختلاف بالوظائف الكيميائية والفيزيائية للأمينو acids. In this slide, the formation of the peptide bond which occurs between two molecules of the amino acid. the peptide bond formed between the carboxyl group from one amino acid and with the amino group from the other amino acid with liberation of the water. البوند البيبتايد بوند راح تتكون من اتحاد الكربوكسيل جروب of one amino acid with the amino group from the other amino acid ومع liberation of water. هذا البيبتايد bond will be formed between each amino acids and form sequence of the amino acids and these of the peptide bond lead to the formation of polypeptide, and the polypeptide will be formed the entire protein. Proteins can be formed using 20 different building blocks for amino acids. Each of these amino acid building blocks have different chemical structure and different properties. Each protein has a unique amino acid sequence that is genetically determined by the order of nucleotide bases in the DNA, the genetic code. Since each protein has different number and counts of the 20 available amino acids, each protein has a unique chemical composition and structure. That means that there is a variety of proteins, there is a large number of proteins that differ in the number and the sequence of each amino acid. And these variability in the number and sequence of the amino acids give different types of the protein and also responsible for the different function of the protein related to the different of the chemical and physical properties of the building block of the amino of the protein, which is the amino acid. So a change in just one amino acid can change the structure and function of the whole protein. For example, sickle cell anemia is a disease that results from altered structure of the protein hemoglobin, resulting from a change of the 6 amino acid from glutamic acid to valine. This is the result of the single base pair change at the DNA level. This single amino acid change is enough to change the conformation of the hemoglobin, so that this protein clumps at lower oxygen concentration and causes the characteristic sickle-shaped red blood cells of the disease. As we said, any change in the number or in the sequence of the amino acids that form the protein, it will lead entirely different type of protein. For example, any change in the amino acid that form the protein, which is the hemoglobin, in which the change of amino acid from glutamic acid to valine. This is change in the single amino acid lead to the different hemoglobin, what is called hemoglobin S or hemoglobin second. That means the shape of the RBC, which contain the hemoglobin, it will be changed from biconcave shaped RBC to sickle-like shape of the RBC. By this change in the one single amino acid due to the change in the configuration of the hemoglobin and the entire RBC, which make the RBC more rapidly break down all lyses by shorter time, lead to a disease called sickle cell anemia. As we said, there is a 20 essential amino acid, 20 amino acid divided into essential amino acid and non-essential amino acid. Essential amino acid in cells, it should be taken in the food, while non-essential amino acid, the body will be synthesizing these amino acid whenever there is need for this amino acid. Essential amino acids include histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. While non-essential amino acids are adenine, arginine, asparagine, aspartic acid, cysteine, glutamic acid, glutamine, glycine, proline, serine, and tyrosine. فيما يخص تسمية amino acid إن either one letter abbreviation بمعنى إما نعتمد على الحرف الأول من على حرف واحد بالنسبة لتسمية الأمينو أسيد أو three letter abbreviation اللي هو more common نعتمد على قراءة حروف التسمية. For example alanine in one letter abbreviation الرمز مالته يكون A while in three letter abbreviation راح يكون ARA. الأرجينين R والثري letter ARG وهكذا فيما يخص بقية التايب أوف أمينو أسيد. هذا هو التكملة لبقية الأمينو أسيد وال either one letter or three letter abbreviation. Classification of amino acid. Amino acid can be classified in four ways. First, based on structure. second based on the side chain character. قلنا هذا السايد chain character يعني الار جروب or molecule in the R group. Third, based on the nutritional requirement. Fourth, based on metabolic fit. ما راح نتطرق بصورة تفاصيل أكثر عن الكلاسيفيكيشن الكيميائي لأن يحتاج له محاضرة أو أكثر من محاضرة، فراح نتطرق بس حبيت نوضح بالنسبة للكلاسيفيكيشن of the amino acid هو according to these four ways اللي based on the structure, on the side chain, nutrition requirement, and based on the metabolic fit. Properties of amino acids. Physical properties. Solubility. Most of the amino acids are soluble in water and insoluble in organic solvent. Melting point amino acids are generally melt at higher temperature or often above 200 centigrade. Taste. Amino acid may be sweet like glycine, alanine, valine, or tasteless like leucine, or bitter like arginine or isoleucine. Monosodium glutamate is the scientific compound is used as a flavoring agent in food industry Chinese food to increase taste and flavor. هذه المركبات مصنعة اللي يزيد من الطعم ورائحة بعض الأطعمة خاصة الأطعمة الصينية. Classification of some proteins and their function. Class of the protein. First, structural. Provides structural component. An example of protein is collagen and keratin. This is important in the structural part of the body. Second, contractile types of protein اللي هو related to the movement of the muscle or muscles. An example of the myosin and actin. This is an important protein in the muscle associated with the contractility of the muscle. Third, transport اللي carry essential substances throughout the body. An example of hemoglobin, which carry oxygen and CO2 from lung to the tissue and vice versa. The other lipoprotein, which carry the lipid from the site of the synthesis to the site of the use. Then hemoglobin, lipoprotein as an example for the transporter type of protein. Other storage, they store nutrients like casein, protein. Casein is stored for the milk, while the protein is a protein responsible for the storage of the iron. The other class of the protein, the hormones. Many hormones are protein in nature. That hormones have wide function in the body that regulate body metabolism and nervous system. An example of the hormone function of the protein, well, insulin and growth hormone. Insulin and growth hormone are proteins, hormones have many functions in the body. Other class of protein were enzyme. The enzyme catalyzed by chemical reaction in the cells like separase and trypsin. Another were protective or protecting class of protein recognize and destroy foreign substance like immunoglobulin. Immunoglobulin is a part of the protein, has protective function. It is defense mechanism هو عبارة عن وظيفة دفاعية against the foreign substance. Against the foreign substance. Four levels of organization of protein structure. First, primary structure. In primary structure, refer to linear sequence of amino acids that make up the polypeptide chain. The primary structure of protein refer to there is a sequence, linear sequences of the amino acid that form the protein. This sequence is determined by the genetic code, the sequence of the nucleotide of the DNA, as we say the whole protein under the control of the DNA. The sequence of amino acids determine the position of the different RB groups relative to each other. بمعنى أن the R group will be positioning in relative to others in these linear sequences. This position therefore determines the way that the protein falls on the primary structure of the molecule. Four levels of organization of protein structure. Primary structure. Primary structure refers to the linear sequence of the amino acid that make up the polypeptide chain. بمعنى organization or sequence of the amino acid in this primary structure protein occur in linear chain. These sequences is determined by the genetic code, the sequence of nucleotide base in the DNA. As we said, the whole protein synthesis it's under the control of the DNA. The sequence of amino acids determines the position of the different R group relative to each others. And this positioning therefore determines the way that the protein falls and the final structure of the molecule. This is an example of primary structure of the protein. If this type of the protein has a pentapeptide bond, as you see in this slide, there is 5 peptide bond that link the amino acid, and the protein starts by the amino group, the terminal residue, amino terminal residue on the left side, and the end by the carboxyl group on the right side. And each two molecule of the amino acid are bound by the peptide bond. So this is a protein of a pentapeptide protein, where an R group in this protein are all positioned in the same side, which give the linear sequences, which give the linear structure or the primary structure of the protein. Secondary structure. The secondary structure of protein refers to the formation of a regular pattern of a twist and kings of the polypeptide chain. معناها انطواءات in the polypeptide chain, which differ from the primary structure, in which there is a linear chain or there is a linear sequence of the amino acid. The regularity is due to the hydrogen bond formed between the atom of the amino acid backbone of the polypeptide chain. ما يعتمد على الهيدروجين bond between the backbone of the amino acid. The two most common types of secondary structure are called the alpha helix and beta pleated sheet. There is two types of secondary structure, which is called alpha helix and beta pleated sheet. In this slide, there is an example of alpha helix secondary structure of the protein, in which the protein are twisted in one side according to the hydrogen bond formed between the molecule of the amino acid, and this is the called right-handed alpha helix of secondary structure of the protein. While in this slide there is a beta pleated sheet and anti-parallel pleated sheet, in which the sequence of the amino acid lie in two lines parallel one parallel to each other. And this is an example of beta entity of secondary structure of the protein. Tertiary structure. Tertiary structure refers to the three-dimensional globular structure formed by bending and twisting of the polypeptide chain. Now, in tertiary structure, there is bending and twisting of the polypeptide chain of the protein in three-dimensional way, give the structure of protein globular in shape. This process often means that the linear sequence of the amino acid is folded into a compact globular structure. The linear sequence with the bending and the twisting of the polypeptide chain give the shape of the globular shape of the protein structure, which is the tertiary structure. The folding of the polypeptide chain is stabilized by multiple weak non-covalent interactions. These interactions include hydrogen bond that form when hydrogen atom is shared by two other atoms, electrostatic interaction that occur between charged amino acid side chain. Electrostatic interactions are attractions between positive and negative sides on macromolecules. The stabilizing for the three-dimensional tertiary structure of the protein occur by the hydrogen bond and by the electrostatic interaction in which there is between positive and negative sides. The folding of the polypeptide chain is stabilized by multiple weak non-covalent interactions. These interactions include hydrogen bonds that form when a hydrogen atom is shared by two other atoms, and electrostatic interaction that occur between charged amino acid side chains. Electrostatic interactions are interactions between positive and negative side on RF molecule. And so the stabilizing form of the tertiary structure of the protein occurred by the hydrogen bond, which is similar to the secondary structure of the protein, and by electrostatic interaction, which occur between positive and negative charge in the R group of the amino acid molecule. Other stabilizing form is the hydrophobic interaction. During folding of the polypeptide chain, amino acids with the polar, that means water-soluble side chain, are often found on the surface of the molecule, while amino acids with the non-polar, water-insoluble side chain are buried in the interior surface. This means that the folded protein is soluble in water or aqueous solution because on the surface there is a polar or water-soluble side chain, while in the inner surfaces there is water-insoluble or non-polar side chain. Other covalent bonds may also contribute to the tertiary structure. The amino acid cysteine has an S group as a part of its R group, and therefore the disulfide bond can be formed with the adjacent cysteine. For example, insulin has two polypeptide chains that are joined by two disulfides. That means, in addition to the factor that mentioned that make stabilization for the tertiary structure of the protein, which is the hydrogen bond, the electrostatic interaction, hydrophobic interaction, a certain time of the protein, which contain a cysteine molecule or cysteine amino acid, there is an additional stabilizing factor, which is the combination or bond between disulfide group that is present in the cysteine amino acid. This is an example of insulin, which has two polypeptide chain that are joined by two disulfide bonds. Quaternary structure. Quaternary structure refers to the fact that some protein contain more than one polypeptide chain, adding an additional buffer of structure organization. The association of the polypeptide chain. Each polypeptide chain in the protein is called subunit. The subunit can be the same polypeptide chain or different ones. For example, the enzyme beta-galactosidase is a tetramer, meaning that is composed of four subunits. And in this case, the subunits are identical. Each polypeptide chain has the same sequence of the amino acid. That means in quaternary structure, there is more than one polypeptide chain, and these polypeptide chains are called subunits, or these subunits form the tertiary structure of the protein, and each subunit has the same number and sequence of the amino acid in each part of the polypeptide or subunit. Hemoglobin is another example of the tertiary structure of the protein. Hemoglobin is the oxygen-carrying protein in the blood. Is also a tetramer, that means composed of the four subunits of the polypeptide, but is composed of two polypeptide chains of one type, that means has 141 amino acids, and two of different types which contain 146 amino acids. In chemical shorthand, hemoglobin is referred to alpha 2 and beta 2. That means alpha 2, which means two subunits, two polypeptides have the same number and sequence of the amino acid, and two beta 2 subunits or polypeptide chain, which is have another different number and sequence of the amino acid. For some protein, quaternary structure is required for full activity function of the protein. As we said, the shape or structure of the protein is related to the function. According to the function of the protein, the structure will be changed from the primary, secondary, tertiary, and the quaternary structure.